Good day, folks. Today we're going to take a look at how to factor a trinomial when a is 1. So our objective for today is factoring trinomials of the form ax squared plus a bx plus a c, as it shows right here, when our a value is a 1. In other words, that value right there is going to be a 1. When we're all done today, you'll be able to do something like factor something like what I'm circling right there. Okay, our Wicker No Undo is there as well. Please make sure this is down in your Cornell notes. And our essential question for the day, what is factoring? Okay, well let's begin this lesson. We're going to take a second and we're going to review. Now, when we review, take a look at this problem that I put right here. If we take a look at this problem right here, here's two binomials. Now let's review a second multiplying those. If we take those and we multiply, notice you're going to take the x times the x. You're going to distribute the x into the x plus 5. So it could be x times x plus x times 5, giving us x squared plus a 5x. Then you're going to take the 2 times the x and then the 2 times the 5, and that's going to give us plus 2x plus 10. You add the like terms together and you will get x squared plus a 7x plus a 10. Now, there's something I want you to notice here. Today what we're going to do is we're going to go backwards with it. I'm going to give you what I just underlined here, and we're going to go back to factors. So, when we multiply, you multiply two binomials to make a trinomial. Now we're going backwards. We're making a trinomial into two binomials. Okay, so that's where we're going today. That's our objective. To start out today, there are two ways of factoring this problem. The first method is called a guess and check method. Now, with the guess check method, first of all, it indicates because you have x squared here. Therefore, I am going to put an x here and an x there because I know that when I multiply x times x, that's what gives me right there. Okay, I know that. The second thing that I want is I want to know the factors of 36 so that when I multiply them, they give me the product of 36, but their sum is going to be 15x. Okay, so what I'm going to do is I'm going to write down each of the factors for 36, and we're going to take a look at the sums to see just what it can give me. For example, my first set of factors, I can take 1 times 36, are the factors of 36, and when we add 1 plus 36 or 1 plus 36 together, of course we will get 37. Now ask yourself, is that 37? Remember what we're wanting here? We are wanting to get 15x. Okay, so that one doesn't work, so we can say nope, that one's not it. Next, let's take a look at this set of factors here. I can have 2 and 18. Now if I add those two together, 2 plus 18, what does that give me? Well, that gives me 20. And is 20 equal to 15x? Nope, that's not it. Okay, so let's try another. How about 3 and 12? Well, 3 times 12 is 36. What's 3 plus 12? Well, that's 15. Okay, so that one does work. So that tells me that the factors of this trinomial will be this right here. Okay, so let me uncover this here, and our final answer will simply be this. The factorization of x squared plus a 15x plus a 35 gives us x plus a 3 and x plus a 12. Okay, the guess and check method usually is not the most efficient method of factoring a trinomial. For example, if we look at these two products, x plus a 3, x plus a 4, and if I multiply, if I distribute x plus a 3 into x plus a 4 and multiply these two binomials together, notice x times x gives you x squared. Then I will get x times 4 gives me 4x. 3 times x gives you 3x. The sum of 3x plus 4x equals 7x. And then 3 times 4 equals 12. Now, I want you to notice something. If you take a look at the coefficient of the middle term, this term is called the linear term. By the way, just for your notes, off to the side, I want you to label the parts of a trinomial. This is called the quadratic term. Okay, everybody write that down in your notes. Okay? This is called the linear term right here. And this over here is called the constant term. Now I know some of you are probably not writing this down, so I'm going to tell you again. Write this down. Okay, this term right here is called the quadratic term. This term here is called the linear term. And this term here is called the constant term. Now I want you to take a look at what happens here. The coefficient of the middle term, the linear term, is the sum of 3 and 4, which are the factors of 12. And of course, the third term, also known as the constant term, is the product of 3 and 4. Now we're going to use that idea, and we're going to teach you a method on the next slide. Now the method that I'm going to show you right now works for any trinomial, okay, of this form that I'm circling right there. So here's a trinomial. We have x squared plus a 9x plus an 18. I want to know what are the factors of 18 that add up to be 9. Okay, so here's the factors. I have 1 and 18. I have 2 and 9, 3 and 6. So let's look at which one of those are going to add up to be a 9. Well, 1 plus 8 is 1 plus 18 is 19. Not it. 2 plus 9 is 11. Not it. 3 plus 6 is 9. That's it. So that just simply means our factors are going to be x plus a, 3, and x plus a, 6. And you're done. You factored it. Now what happens when the c value is positive? Okay? When c is positive, its factors have the same sign. If the b value is negative, they're both negative. If the b value is positive, they're both positive. Now, what in the world am I talking about? Well, let me quickly do a real quick example for you, see if I can explain. So let's say that I have x plus bx, x squared, plus bx plus a c. That means my factors are going to be x plus something and x plus something. Now, if I happen to have x squared minus a bx plus a c, that means my factors are both going to be negative. It's going to be x minus something and then x minus something. Okay, let's use this idea and see if we can do a problem. Here's our first problem. Now, what I'm going to do is I am going to tree this out. In other words, I'm going to do a little tiny, we're going to do a factor tree here. Now, what are all the factors of 9? Well, I have 3 times 3. Now, notice here, the constant term is positive. My linear term is positive, which means both of these are going to be positive. So that gives me 3 and 3. Then I have 1 times 9 and 9 times 1. Now, which one of these are going to give me this term right here? I want a 6. Okay, so which one are going to give me 6? Well, look here. 3 plus 3 is 6. So that tells me that this is my factor combination that's going to work. So I'm going to come over here and I'm going to say that that is equal to, and it's going to be x plus a 3 and x plus a 3. Now, don't stop right there. Notice what I said here. I said check your answers, which means what I want you to do is you're going to distribute. So I have x times x gives you an x squared. X times 3 gives you plus a 3x. 3 plus x gives you plus a 3x. And 3 times 3 gives you plus a 9. Now, I'm going to add like terms. These are my like terms. So I will get x squared plus a 6x plus a 9. Now, is this what I originally started with? Yes, it is. So what does that tell me? That tells me that this right here, this thing that I'm boxing right there, is my factor combination that works. Those are my factors of the trinomial. Okay, let's try another one. Now notice what I'm seeing here. I'm seeing the constant term is positive and the linear term is negative. Now that tells me right there that whatever I do, whatever my factors are, I know it's going to be x minus and x minus. I just have to figure out which of those it's going to be. So first of all, we're going to find all the factors of 15. So let's see. I have negative 3 times negative 5. I have the reverse of that, negative 5 times negative 3. I have negative 1 times negative 15, and negative 15 times negative 1. Now, which one of these combinations here is going to add up to give me negative 8? Well, let's see which ones do. So, I'm going to have negative 3 plus negative 5, which gives me negative 8. Yep, there it is. I don't have to go any further. Now, I do want you to know that this here also would have given me negative 5. So, or 8, I'm sorry, would have given me negative 8. So it turns out that, and I'm going to write all these sums down, turns out I could have chosen either this one or this one. Okay, so it doesn't really matter. And so let's go ahead and put those in place. So I am going to put x minus a 3 and x minus a 5. And now, of course, we need to check it. Why do we need to check it? Because I said to check it. So let's go ahead and check it. So let's see. X times x gives you a x squared. X times negative 5 gives you minus a 5x. Negative 3 times x gives you negative 3x. And negative 3 times negative 5 gives you plus a 15. Let's add like terms. These are my two like terms. So I have x squared minus 8x plus 15. Now, look, is that the same as what I had? If it is, that means that these are my factors to the trinomial. Now that we've taken a look at how to handle situations when my constant term is a positive, let's take a look at a few examples of when our constant term is a negative. How do I handle that? Well, here's what it's going to look like. If my constant term would be negative 14, that means my negative will always be on the inside. Okay, so we're going to go negative 2 times 7. Now remember, negative 2 times 7 is negative 14. Then we flip it around and go the other direction. Negative 7 times 2. Negative 1 times 14. Negative 14 times 1. So these are my factors. This is the way we would write it for the factors of negative 14. Okay, now let's go do a problem using this situation when c is negative. Okay, here's our problem. I have x squared plus an x minus a 20. Alright, so here's what I'm going to do. Now remember, we're putting the negative on the inside right here. The inside meaning we're putting it toward the inside term. We're keeping it on the left side. Okay, so anyway, let's go ahead and show this. So I could have negative 4 times 5. I have negative 5 times 4. I have negative 2 times 10. Negative 10 times 2. Negative 1 times 20. And negative 20 times 1. Now we're going to add up each of these to see which one of these is going to give me a 1 right here. Now you may say, I don't see a 1 there. Well guys, there is an imaginary 1 right there. Because how many x's do you see? You see 1x right there. Okay, so now let's go add these up. So negative 4 plus 5 gives you 1. There it is. We just got it. Now I'm going to just go ahead for the sake of writing these down. I'm going to finish it out. You can stop after you find the one that works. Okay, so we can look here. I can see that this one here is the one that works right there. So that means my factors are going to be, now notice because my negative is the first one, that means I have to have an x minus 4, and then I'm going to put an x plus 5. Now maybe you don't see why I put minus 4 plus 5, because this says minus 4, and then it says 5. If you don't have a sign, that 5 is plus. Okay, so that's why I put that there. Now we're going to multiply. So x times x is x squared. X times 5 is plus 5x. Negative 4 times x is minus 4x. And negative 4 times 5 is negative 20. Adding like terms, that gives me x squared plus an x minus a 20. Now look at this. Is that what I originally started with? If it is, then that means this is my answer. It is the factors of this trinomial. Now, let's take a look at when it looks like this. Notice here, I have a negative linear term and a negative constant term. Now, remember what the rule was that I gave you a couple slides ago. If my constant is 0, that means, matter of fact, I don't care what this is. If my constant term is negative, that means my factor combinations will be one negative and one positive, which means I'm going to have negative 6 times 3. Then I'm going to put a negative 3 times 6, and a negative 2 times 9, negative 9 times 2, negative 1 times 18, and negative 18 times 1. And by the way, these are times, not subtractions. Just clarify that. Okay, now we're going to add up each of these, and I'm looking for a negative 3. So, negative 6 plus 3 gives us negative 3. There it is. Now, for the sake of doing this, I'm going to work this out. Okay, you can stop again when, when you do your homework. You can stop when you find it. But this is how each one of these will work, and you can see that this is the one that works right here. So I'm going to circle that, and then I'm going to come over here, and it's going to be x minus 6. Again, you need to keep it in this order. The negative 6 is first, so you put it there. The positive 3 is second, so you're going to put it over there. Okay, so it'll be x plus a 3. Now, let's check it. X times x is x to the second. X times a 3 plus a 3x. Negative 6 times x, negative 6x. Negative 6 times a 3, negative 18. Adding like terms, these are my like terms. So I have x squared minus a 3x minus 18. And now, take a look at that. Is that what we originally started with? Yes, it is. So that means this is my answer. It is the factored form of that trinomial. Okay, guys, that's going to wrap this up for today. Your assignment is these problems. Okay, so what I want you to do is we're going to stop here for today. You can stop right where you're at. Your notes are completed. And on your iPhone, if you want to snap a picture of your screen, or on your Android device, you can, snap a picture of the screen. Then you have the problems. We're going to be working these problems right here. So this is the page. All right, guys. Well, I'll see you in class. Have a good day.